Hello everyone. In this video, we shall discuss section 10.4 perpendicular from the center to a chord of a circle. So under this section, I have two theorems, theorem 10.4 and theorem 10.5, right? So let's look at theorem 10.4 first. It states the perpendicular from the center of a circle to a chord bisects the chord. Okay, so what this means is, I'll draw a picture. From the center of a circle, if you draw a perpendicular to a chord, right? So let's say I have a circle and I have a chord with me. And from the center, let's say this is the center, I'll draw a perpendicular to the chord. So this perpendicular which is drawn, I have to prove that it bisects the chord. Okay, let's take a center O. So take a circle with center O and we will take a chord. Okay, so let's say I name the chord AB. So we have drawn OP, let's say, perpendicular to AB. So draw OP perpendicular to AB. Now this perpendicular which we have drawn on the chord, we have to prove that it bisects the chord. That means it divides the chord into two parts. So we have to show that AP is equal to BP. Okay, so we have to prove that AP is equal to BP. So to do this, what you do is, you will join AO and you will join BO. So two triangles are formed. We will prove that these two triangles are congruent and therefore by CP/CT, AP will be equal to BP. Right? So first in triangle, I'll name the triangles AOP and BOP. In triangle AOP and triangle BOP, first you observe that there is a right angle. OPA and OPB is a right angle. So angle OPA is equal to angle OPB. The reason is right angles. Then you can say that OA is equal to OB because they are radii of the same circle. Radii of same circle. And then you can see that OP is also the common side. So I can take that up. OP is equal to OP, common side. So by right angle hypotenuse side, RHS congruence rule, they are congruent. Therefore, triangle OPA, or I named it AOP, is congruent to triangle BOP. So reason is RHS congruence rule, and therefore by CP/CT, AP will be equal to BP. That will be point number 5. So that is by CP/CT. So what this basically says now, if you have a circle, let's say, and there is a chord here whose length is 10 centimeter. And if you draw a perpendicular here, then it will bisect it. That means it will break it into two parts, and each part will be of length 5 centimeters. So it is going to break it into two halves, which are equal. Okay, so that is theorem 10.4. Now the converse of this is what? Theorem 10.5 is converse of the previous one. The line drawn from the circle, from the center of a circle to bisect a chord is perpendicular to the chord. So now it is not told to you that you are drawing a perpendicular. So what this one says, there is some circle here and there is a chord. Okay, so let me draw this chord. Again, let's name it AB. And from the center, now you are dropping one line. There is one line, you don't know whether it is perpendicular or no, in such a way that it is bisecting the chord. You have to show that this is actually a perpendicular that you have drawn. Okay. So there is a chord and there is a line from the center which is bisecting the chord. That means it is breaking the chord into two parts. We have to prove that it is perpendicular. Okay, so again we are going to take a circle. Take a circle with center O and chord A. Okay, and there is a center O here, so I'll have to name this O. And OP is drawn here to join AB. So AB is this chord, and we know that OP bisects AB. This is given. What is the meaning of this? AP is equal to BP is given to you, and you have to prove that this is a right angle. So what you will do? Again, you will have to join OA and OB in this manner, and you have to show that these two triangles are congruent, and by CPCT, these two angles will be equal, and they are also forming a linear pair. So each one is will be 90. That is what I have to prove. So again, I'll take both the triangles, and we have to show that OP is perpendicular to A. Okay, so in triangle AOP and triangle BOP, firstly OP is the common side. So OP is equal to OP, common side. Then we have OA is equal to OB, radii of same circle. Reasoning is very important. Radii of same circle. And AP is equal to BP, that is given to you. Okay, so this is given to you. So by SSS congruence rule, both the triangles are congruent. Therefore, triangle AOP is congruent to triangle BOP by SSS congruence rule. And therefore, by CT, this angle will be equal to this angle. So OPA is equal to OPB. Therefore, OPA, angle OPA is equal to angle OPB by CT. Okay, let the common value, I'll call it X, let's say. But both of them also form linear pair, right? So this is X, and I know that they are equal now. So by linear pair axiom, angle OPA plus angle OPB, their total will be 180 by linear pair axiom. Right? So, but both of them are equal to X each. So X plus X is equal to 180. That means 2X is equal to 180. And once you transfer 2 on the other side and cancel, this will come to 90. That means each of them is 90 degrees. So this is 90 degrees and this is also 90 degrees. Right? So therefore angle OPA is equal to angle OPB and each of them is 90 degrees. That means OP is perpendicular to it. So if a line is bisecting the chord, then it has to be perpendicular to the chord and it will make 90-degree angle with the chord. Okay, so this session ends here. I'll continue in the next session. Thank you.